Alright everyone, so right now I'm going to give you a slight video to talk about the further exploration tasks that aren't really homework and aren't really anything, but I want you guys to talk about them, do them, see what's going on here. So the first task says consider the function 2 to the x. Some people think that f prime of x is equal to x times 2 to the x minus 1. On the basis of the conjecture that we made, explain why this cannot be true. So let's go over to our conjecture here. So it's on this page, and we have the conjecture. When the function is rising, the derivative is greater than 0. When the function is falling, the derivative is less than 0. And at a maximum or a minimum, the derivative of the function, the maximum or minimum of the function, the derivative is 0. So Amanda gave a good explanation in class that I really like that I'm just going to reiterate here. So Amanda said that if the function is 2 to the x, well, 2 to the x is always rising, meaning that 2 to the x is always less than 2 to the x plus 1 for any x we have here. And similarly, 2 to the x is always greater than 2 to the x minus 1. So this function is always rising, as Amanda graphed right above this, and the derivative, if the derivative is x times 2 to the x minus 1, then that, in some cases, will not be positive. And we know from this first rule that if the function is rising, which 2 to the x always is, then the derivative is always positive. Well, let's take an example value. So I believe we used -1 in class. So at x equals minus 1, we have minus 1 times 2 to the minus 2, which is -1 over 4. Which is definitely not greater than 0, because it's a negative. And now I want to talk to you guys about another one, and this has to do with the maximums and minimums. And that's in fact why I brought this little guy, this always less than, into the picture as well. So what I want to talk about here is, what if we have the case where we say there's no maximum, no minimum? Because no matter what, there's going to be x increasing the function if x is increasing, or decreasing the function if x is decreasing. Because this function, again, looks something like this. It's always going to be going up. But if we have the derivative to be x times 2 to the x minus 1, and we say at x equals 0, then we have 0 times 2 to the 0 minus 1, which is just equal to 0. And from our rules, when the function is equal to 0, or when the derivative is equal to 0, the function should be at a maximum or a minimum. So this is another way to contradict this being the derivative. Let's move on to the next one. So this next one, they say, we're going to give you a graph of f prime of x. Can you use our rules, so the rules right up here, to find the graph of f of x? And I say, yes, we can. So how we're going to do this is, we're first going to look section by section. So I'm just going to section off the leftmost section here. And we're going to say, well, what's the derivative there? The derivative is negative. And let's look back at the rules. When the derivative is negative, f prime of x is less than 0. The function is falling. So let's draw our function in red, and we'll draw the function is falling. So we'll start up high, and we're going down. And then what happens here is the derivative is 0. Well, at the derivative being 0, we either have a relative maximum or relative minimum from our rules to the right. And in this case, it's going to be a minimum, because directly after the 0, we have our function is rising because our derivative is positive. So we'll have something that looks like this. We'll have the function, the minimum, and then rising. So I'll even show that minimum with the tangent line of 0 slope. Then we have another 0. So I'll draw in this 0 here. So I may have gone a little overboard drawing. So this 0 will have a tangent line somewhere around here. And we'll say, okay, so that's our 0. And you'll see I got right into the negatives again because the derivative is below 0. So derivative below 0 means our slope of our function is negative, not necessarily decreasing. And then right here is our next 0, and we're going to go positive from there. So the derivative slope is positive after that 0, so we're going to have a minimum. And let's just draw that in really quickly. So we have the minimum and then the positive slope. So again, when the derivative is 0, we have that 0 slope. And then when the derivative is positive, we have that positive slope. And then finally, let's talk about this last position, acceleration, velocity one. So I don't know if you guys remember or learned this in the summer calc course, but let's call position S of t. Well, the rate of change of the position is the velocity at which the position is going. But the rate of change of the position is also just called the derivative of the position, the slope of the position. So if S of t is the position, then S prime of t is going to be our velocity. And then similarly, the rate of change of velocity is going to be equal to our acceleration. How fast are we changing speed? And then that would be the second derivative of our position. So let's label these lines A, B, and C. And I'm just going to circle the first thing that I see that stands out. And to me, that is this and this. So on in the first circle here, I have this point, which is the graph of C crossing the x-axis, a 0 for C. And when I see a 0, I go over to the right and I look and I say, well, 0. If the derivative is 0, then it's either a maximum or a minimum. And then on B, I immediately see a horizontal tangent line, which shows me that this is a maximum. So this automatically tells me that C is equal to the derivative of B. Because when the derivative is equal to 0, the function itself has some kind of maximum or minimum. So the next thing that I notice personally, this may be different for you, is that this function A is always increasing. It looks almost as the 2 to the x graph did, just a little bit different rates of increase, but this function is always increasing. That means to me that the derivative of this function, so A prime, has to always be greater than 0. It's greater than 0. And the only function who is always greater than 0 that's not A itself is B. You'll notice that B does not cross the x-axis whatsoever. Here it gets a little close, but B stays above the x-axis. So I know that A prime is equal to B. Well, if A prime equals B and B prime equals C, that's the same as saying that, I'm going to extend the page a little to work on this again. So A prime equals B, B prime equals C. Well, isn't B prime just the same thing as A double prime? So if A double prime equals C, and that looks an awfully lot like what we have here. So we would call A our position, B our velocity, and C our acceleration. So I'm going to grab these, pull them up here, and erase a bit other just for a final shot. So you guys can talk about this. I should not have erased those. So we have A, B, and C. Thanks for doing those problems and watching this.